So we are going to look at section 8.1 today, which is page 551. And we are going to look at variation today. All right. So there are a couple different types of variation that we're going to talk about today. The first type is direct variation. We also have inverse variation, joint variation, and something that I call combination variation. So those are the four different types of variation we're going to talk about today. Variation is pretty easy, but you guys have to understand what's really going on. And then you have to just set them up correctly. So the first thing we're going to do is we're going to talk about direct variation. Direct variation looks something like this. Y varies directly as X. This translates as Y equals, and your book uses the letter A times X, where X and Y are your two variables, and A is called the constant of variation. It's what gives us the relationship between the X values and the Y values. Okay? And A cannot be 0. Otherwise, that means there's no relationship between the two. So Y is equal to A times X. So for example, Y equals 2 times X, Y equals 5 times X, Y equals negative 1/2 times X, whatever it is. Now typically what they'll do is they will tell you that when X is equal to 3, Y is equal to 15. And then they're going to ask you to find, well, there's 3 different things they can ask you to find. So let's just talk about this part first. So Y varies directly as X is Y equals A times X. Now, based on how this is worded, guys, that determines how your equation should be set up. If they said X varies directly as Y, you would say X equals A times Y. If they said P varies directly as W, it would be P equals A times W. Okay, it's multiplication here. Now, there's a couple of different things that they can ask you to do. One of the things they can ask you to do is find the constant of variation. In order to do that, you start with your Y equals A times X, and you plug in your X value and your Y value that they gave you. Divide both sides by 3, and you get A is equal to 5. This is your constant of variation, and it is going to stay the same value for A throughout the entire problem. Now, in the next problem, A will take on a different value, but for this problem, A stays 5. Excuse me. That means that Y is always 5 times whatever X is. And so that's the second thing they could ask us, is they could ask us to find the equation of variation, or the equation relating the variables. That equation has to have the variables in it. So we go back to our Y equals A times X, but this doesn't tell us the exact relationship between the variables. It's not the exact relationship until we take out the A and we put its value in. This is the equation of variation, or the equation relating to variables. Does that make sense, everyone? So you go back to your Y equals A times X, but you plug the number you found for A in. So now we know that A or Y is always 5 times as big as whatever X is. Now the third thing they can ask you to do is they can ask you to find a new value of one of the variables when they give you a new value of the other one. So let's say x equals -2, they want us to find y. So now we use our equation, y equals 5 times x, and now we're going to plug -2 in for x. So y equals 5 times -2, which means that y equals -10. So those are really the three different types of things they can ask you. Notice, regardless of whether they ask you the second one or the third one, you always have to do the first one. You have to find the constant of variation first. In order to do the third one, you have to first do the first one and the second one, because we need both the constant of variation and we need the equation of variation, the equation relating to variables, to do the third part. Okay, so does that make sense, guys? Easy enough? Okay, y equals a times x, direct variation. The reason it's called direct variation is x and y vary directly. They move the same direction. If y is equal to 5 times x and x gets bigger, what happens to y? It gets bigger. If x gets smaller, what happens to y? It gets smaller, right? And if instead of 3 giving me 15, I plug in 2, I only get 10. So they move the same direction. That's the idea. Okay, the next thing is we want to talk about inverse variation. Inverse variation, so y varies inversely as x, means that y is equal to a divided by x this time. So when x equals 8, y equals 4, they could ask us to find the constant of variation. So y equals a times or over x. So that tells us that 4 equals a over 8. What do I do to get a by itself? Multiply the whole thing by 8, which gives us a equals 32. So there is the value of our constant of variation. What is our equation then that relates to variables? Y equals 32, which is a divided by x. So notice, guys, as x gets bigger, what happens to y? Smaller. When you divide by a bigger number, you get a smaller answer, right? And when x gets smaller, y gets bigger. So that's the idea of inverse variation. The direction that one moves is opposite from the direction the other one moves. Excuse me. Finally, they could ask us to find x when y equals 2. So now we plug a 2 in for y. Multiply both sides by x, and that gives us 2x equals 32. And then we divide both sides by 2 to get x by itself. X equals 16. Okay? So again, those are the three different things they can ask you for. Questions about that? So direct is y equals a times x. Inverse is y equals a divided by x. Now we're going to look at joint variation. Joint variation is just direct variation with one or more extra variables. Morgan, you got a question?
I'm sorry, could you possibly go back?
Sure. So joint variation is just direct variation with one or more extra variables. So instead of just x and y, now we're going to have maybe x, y, and z, or w, x, y, and z. We have extra variables thrown into the mix. Okay? So this is direct with one or more extra variables. So more than 2 variables, greater than 2. So for example, y varies jointly as x and the square of w. What does that translate into? Well, y varies, so y equals, jointly is direct, just with extra variables. So it's going to be a times x and the square of w. How do I write the square of w? W squared. So this would be our starting equation. Y equals a times x times w squared. So it's all being multiplied because of the joint variation. Joint is just direct with one or more extra variables. And obviously they would now tell you what x, w, and y are. You'd find a, and then you'd plug a back in to get the equation, etc. Questions about that one? That's joint variation. It's just the same as direct, just with one or more extra variables. Direct is only with two variables, x and y, p and w, whatever it is. Joint is more than two. Okay, the last one is what is called combination variation. And that's my name for it. Combination variation is a combination of two or more of the other types. So for example, they could tell you that z varies jointly as y and the square root of x, and inversely as the cube of w. So z varies, so it's going to be z equals, jointly means a times something, right? What does it vary jointly as? Y in the square root of x, so it's going to be y times the square root of x. And inversely means what? Divided by, what goes on the bottom? Cube of w, which is w to the third. Do you guys see how that works? So just translate it in the order that it's written. And then obviously they could give you x, y, z, and w, allow you to find a, and then once you know a, you can plug it back in and get the equation, and you can go from there. That's it. That's the basics of variation. Direct variation, inverse variation, joint variation, combination variation. Questions about that? Now, one of the things that they're going to give you, in addition to those other problems I showed you, is they can give you a table of values. So for example, look at page 555. On page 555, number 20 gives you a table and gives you a bunch of numbers for x and y and says determine whether x and y show direct, inverse variation, or neither. So for example, if I have something that looks like this, and we want to figure out if it's joint, inverse, or neither. Here are my x's, here are my y's. 3, 9, 5, 15, 6, 17, 9, 27. We want to know if this is joint variation, direct variation, inverse variation, or neither. What you do is you grab the first pair of x and y's and you set up your equation. If it's direct, then what equation are we going to use? Yeah, y equals a times x. Now we plug in our y. We plug in our a. Divide by 3, and we get a. I should have done it over here. Sorry, guys. Let me make some room here. Move that over there. And so that gives us a equals what? Now we do the same thing with the next pair. 15 equals a times 5. You divide by 5. which gives you A equals 3. Now you use the next pair. 17 equals A times 6. Divide by 6, and you get A equals 17 over 6. In order to be, let me do the last one, although technically we don't have to. Divide by 9, A equals 3. In order for this to be direct variation, when you set it up and plug it in, A has to be a constant, which means what? It's always the same. Is A always the same for each pair? No. Because of this one, it's not direct. Because A is not always the same. So you don't have to go all the way to the end. You don't have to do them all. As soon as you see two that give you different values, you're done. It's not direct. So what do we have to try next? Inverse. So now you try inverse. For inverse, we get y equals A over x, so that's going to give us 9 equals A over 3, which makes A equal to 27. Now we do the next one. 15 is equal to A over 5, which makes A equal to what? 75. 5 times 15. Do those match already? No. So this one is not inverse. Therefore, it's neither. So try whichever one you think it might be first. You don't have to do direct first. If you think it might be inverse, do inverse first. But if it doesn't work for one of the pairs, then you stop and you try the other one. If it doesn't work for that one, then you know it's neither. If it does work for one, then that's the one it works for. It's never going to work for both, guys. It's going to be one or the other or neither. Those are the three choices. So if you find that it works for direct because you went through all the values and it gave you the same A, then you don't have to do inverse because there's no way it's going to be direct and inverse. Okay, questions about that? All right, that's the idea. So you guys are going to do the following problems. You guys are going to be doing assignment number we're up to number 15. So let me give you assignment number 15.